Okay, good morning. Beautiful day out. There's your joke of the day. Thought it was a pretty good one. Today we're going to be going over the homework, which was the last sheet of the packet, numbers 1 through 8, and we are going to finish up the functional groups. I think we only have 2 left: amines and amides. And then your homework is just going to finish the last 6 of that homework that was on Monday. Okay? So let's look at the homework first, which was this. Okay, so again, you're getting off a little easy here because I would normally make people memorize these endings, but you have your CRT, so it's not going to be nearly as much of a challenge. Okay. This is an organic acid. Ethane indicates that there are 2 carbons. When we're writing these, when we do any of the functional groups, we are always going to count the carbon to which the functional group is attached. So here's ethane, and since it says oic acid, that means I've got to have a carboxylic acid. It's a double bonded O and then an OH. And then I just fill the rest in with bonds showing that carbon always has 4 bonds. This has a common name of acetic acid, as we saw before. And acetic acid, remember, is the active ingredient in vinegar. So this is ethanoic acid. Number 2 is propanal. And prop indicates that there are 3 carbons. Then I would have to go back and remind myself or look up what Al means. Al indicates that it is an aldehyde. Aldehydes have a double bonded O and then just an H attached to that last carbon. Okay, so this, remember, this group here is called the carbonyl group. That's the carbonyl group, C-A-R-B-O-N-Y-L. So I've got 1, 2, 3, and each of my carbons, again, has to have 4 lines indicating it has 8 electrons being shared around it. So there's propanal. Number 3 is octanol. So I need 8. 1, 2, 3, 4, 5, 6, 7. Put the other one over there. 8. 8. So there's octanol. OL indicates that it is an alcohol. Alcohols have an OH group. And when you do alcohols here, you do have to indicate where the hydroxyl group is. Remember, the hydroxyl group is an OH. And you really should be showing this with that bond attached to the oxygen. Because remember, hydrogen can only make 1 bond. So if you were to draw it like this, that's really wrong. You shouldn't put it like that, because that bond right there is going to be bonded with the oxygen. Remember that hydrogens can only make 1 bond because they only have 1 electron that they can share. So that bond right there is shown right there. Okay? I'm done except for filling in the rest. With hydrogens. So there's 2-octanol. Number 4, 1,4-difluorobenzene. Well, you're going to have to go back into your notes where it has benzene in there. Let's see if I still have it. Next one down. So this is in the note packet, and here is benzene. It can be shown in 3 different ways. Most typically it's shown like that. So I need a benzene. It's basically a hexagon And then I can put double bonds every other one. So what do I do with this? This is 1,4-difluoro. So that means I've got a number 1 carbon. It doesn't really matter where you start in this thing as far as this one's named. But this is a fluorine. And if this is number 1, I can go either clockwise or counterclockwise. In this one, we're actually going to end up in the same spot. So 1, 2, 3, 4. So I would have a fluorine here. Or I could go 1, 2, 3, 4. In either case, I'm going to be okay. So this is 1,4-difluorobenzene. Number 5. This is 2-methylpentanoic acid. So I'm going to look at my pent, which is 5. 1, 2, 3, 4, 5. The oic acid indicates that it is an acid group. Carboxylic acid, that's a C double bonded O, and then an OH, as opposed to C double bonded O and H, that would be an aldehyde. So this is my characteristic group of the carboxylic group for acids. So I do count this, 1, 2, 3, 4, 5. And also when I am numbering the carbons in this case, this is always going to be number 1 carbon. Same thing here. The carbonyl group carbon is going to be number 1. So if I had something coming off of this, like maybe a carbon off of here, that would be carbon 1, that would be carbon 2. So this is 2-methylpentanoic, so that's 1, 2. So I need a methyl group off of that, and then fill it in with your lines. Okay, oops. So here's 2-methylpentanoic acid. 2-methylpentanoic acid. And for those people who showed up at the Google Meets on Friday, I guess it was, it's either Thursday or Friday, I think I might have put the carbon there, but it really should go here. Number 6. 3,3-dichloro-1-butanol. OL indicates again that it is an alcohol. Butan means I've got 4 of them. 1, 2, 3, and 4. So I can start here, I guess. 1-butanol. That means I'm going to have a hydroxyl group there. And then 3,3-dichloro. So when I'm naming alcohols as well and building them, the alcohol group, OH, is always going to be attached, I should say that differently. The carbon to which is attached is got to be the lowest number. Okay? So this is number 1, 2, 3, and 4. 1, 2, 3, and 4 as far as carbons go. So that's 1, 2, 3. That's dichloro, there's 1 there, and 1 there. Dichloro-1-butanol. After that, I just fill in my lines for the rest of my hydrogens. 4 and 4. Okay? So there's 1-butanol with 2 chlorines. 3,3-dichloro-1-butanol, OL. Let's move this up. 2 more to do. 1,2-diiodo-1-butene. Okay, but tells me there are 4. Ene indicates that it is an alkene, so there's got to be a double bond. And this tells me that the double bond is at number 1. So 1. So I need a double bond here. I could have started over here, it doesn't really matter. I'm counting from right to left in this case. And then 1,2-diiodo. So remember that when we do alkenes and alkynes, the carbon to which the double bond is attached, that has a double bond, in this case is going to be named. So I already know that this is number 1. So this says 1,2-diiodo. So this is an I, because iodo means iodine. And this is the second carbon. Okay? 1,2-diiodo-1-butene. What's left? Just fill in, make sure you've got 4. Make sure you've got 4, it won't erase, bonds. I think I got it. 4 bonds around each carbon. That little dot didn't erase. So 4 around this one, 4 around this one, 1, 2, 3, 4 around this one, and 4 around this one. Okay? 1,2-diiodo-1-butene. All right, this is a pretty good challenge here. Name this one. Well, I'm gonna have to draw it first. So I'm gonna start on this side, CH3, then CH2, 2 hydrogens, then another CH2, then a carbon. So I already have the 1 carbon on this side, but then it has a bromine over here. So I'm going to put the bromine there. Then in parentheses, it's got a CH2, CH3. So here's my CH2, here's my CH3, then it has CH2, then CH3. Whoops, I almost put CH3. All right, and then my 1, 2, 3 hydrogens there. 1, 2, 3. Okay, what is this thing? Well, I've got to start from this side because my combination could be 1, 2, 3, 3, 3 bromo, 3 ethyl. If I started on the left side, it would be 1, 2, 3, 4, 4. So I always want the lowest combination if that's what it comes to. So this is carbon number 1, 2, and 3. So I've got 3. Now I've got an ethyl group here, 2 carbons is eth, and I've got bromo. So how do I decide which one comes first when naming? We're going alphabetical. So B comes before E. So now I can name it. 3 bromo, 3 ethyl, and what's my long? 1, 2, 3, 4, 5, 6. And there are no double bonds here, so this is a hexane. And 3 bromo, 3 ethyl. Actually, there shouldn't be a dash there. It should be just hexane. 3 bromo, 3 ethyl hexane. Okay? So for your homework tonight, I would like you to finish these 6. Okay, you got a few new ones here. There's a ketone there, pentanone, and there's an ether. Okay? And then we'll do some more practice. The test for this is coming up at the end of this week. Really, what's left here after today is the organic acids, and I'm going to have you take notes out of your review book for that. Okay? So, let's put this aside. Let's see what we have here. Functional groups. We're looking at organic reactions. Nope. We're looking at 5, organic review. Guess I have to pull it up. Sorry. Functional groups blank. Okay, and you can look back on the other videos to review, all of the groups up till here, okay? Because you've got alcohols, you've got organic acids with a C double bond OOH. You've got aldehydes, which also have a carbonyl group, except it's just a hydrogen. Then you've got ketones. Ketones also have a carbonyl group, but it's going to be in the middle of it. somewhere. Then you've got ethers, and ethers are characterized by the oxygen here, and the mnemonic with that was you're going to have substituent groups, quote unquote, on either side of it, okay? And then these are named alphabetically. And then the last one we did was esters, and the mnemonic with that was ester is cool. That means that there's C double bond O, O for these, and that's going to be in the middle. Okay, so this is going to be inside the molecule somewhere. It's not an acid, but it looks like an acid. Acids are C double bonded O, O, just an H here, but this has another group here. Okay? In this case, you're going to name the one on the that's attached to the oxygen on the right side, and then the rest of it. So I name this first, that's why this is methyl, and then I count the carbons again, and that's ethane, but I take away the E and then I end with O8. So that's ethanoate. Okay? So the last two here are amines and amides. Amines and amides. So the NH2 group is called the amino group. So, somewhat similar. I find my longest carbon chain, 1, 2, 3, 4, and then I name the carbon to which the amino group is attached. So this is 1, 2, 3, 4. This is 1 amino butane. Only double bonds, or only single bonds here. So 1 amino butane. Okay? So remember, in these skeletal formulas, each of these angles here has a carbon. So I've got a carbon here, 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 and actually it ends with a carbon. So this is 1, 2, 3, 4, 5. So this is 1 amino pentane. Let's do a different one. So 1, whoops, I can hear you laughing. Aiden, 1, let's try it again. 1, 2, 3, 4, 5. This would be, if I put all my carbons around it, or excuse me, lines around my carbons, for the hydrogens, this would be 3 amino pentane. 3 amino pentane. Okay? There's another group underneath amines, another classification, and you may be familiar with these. I made my kids memorize these. These are amino acids. So amino acids have both an amino group and the carboxylic acid group, and then it has a side chain. In humans, there are 20 different ones, 20 amino acids, and they all have the same characteristic. We've got an amino group, carboxylic group, a hydrogen here, and then a side chain. And it's the side chain that makes it different each time. Whoops, didn't want to do that. The side chain makes it different for each of the amino acids. So here's your side chain. For alanine, glycine is the most simple of them. And if you remember from protein synthesis, these get put together by taking one of the hydrogen off of the amino group and then the hydroxyl group. And then if we were to make this, this would be a dipeptide. And then water would come off. And that process is called dehydration synthesis, and that's how you make proteins. All right? So that's an amino acid, has an amino group. And lastly is amides. Amides have a functional group that has a carbonyl group here and an NH group. Okay? And that's altogether called the amide group. How you name it? Same kind of idea. Root name followed by amide. So what's my group? 1, 2, 3. That's propane. So I'm going to stop with that. And propan. And then amide. It's pretty straightforward. Here's meth, eth, probute. So I'm going to use butane, so that's butan. And then this whole thing here is the amide group, butanamide. Here's your amide group. All right, so those are your 8 functional groups. You should be able to recognize them and name them. All right, let's do a couple more. Wipe it up. Sorry. All right, we'll practice a few of these. 2-pentanol. OL indicates that it is an alcohol. Pent means 5. 1, 2, 3, 4, and 5. You should probably pause and try to do these by yourself. Number 2. That means the hydroxyl group is attached to number 2 carbon. There's 2-pentanol. 1-butanol. But means 4. There's 1-butanol. Remember, I'm putting the oxygen bonded with the carbon. I couldn't put this because, again, hydrogen only has 1 bond. So you've got to have the oxygen bonded there. Okay, 3-pentanone. This means it's in a ketone. Pent tells me 5. 1, 2, 3, 4, 5. 3-pentanone. 1, 2, 3. There's my carbonyl group. And then I fill in the rest with the carbons, the hydrogens that I need, the bonds that I need. 1, 2, 3, 4. There's 3-pentanone. And lastly, number 4, ethanal. Al indicates that it is an aldehyde. ETH indicates that I've got 2 carbons. Remember, in ethanal, it has a double bonded O and then just an H. And then I fill in my carbons. There's ethanal. All right? And that's the end of the notes for the functional groups. What do we have? Some more down here? Let's see how much time we have on this video. It's 23 minutes. Maybe a couple more. We'll just do a couple more examples. How about this thing? 1, 2, 3, 4, 5, 6, 7. Well, I've got a double bond here. So am I going to call it 3 or am I going to call it 4? Well, you want to use the lowest number. So this is 3, because I have to indicate where that double bond is. And what's my long? 1, 2, 3, 4, 5, 6, 7. 3 hep. Double bond means ene. 3-heptene. How about this one? 1, 2, 3, 4, 5, 6. I'm going to choose 2 instead of 4. So this is 2. And again, 1, 2, 3, 4, 5, 6. This is 2-hexene. How about this thing? 1, 2, 3, 4, 5, 6, 7, 8. No double bonds anywhere. So I don't have to say anything except that it is octane. How about this one? 1, 2, 3. 1, 2, 3, 4, 5. So I'm going with the lower one. So this is 3. There's my double bond. And 1, 2, 3, 4, 5, 6, 7, 8. This is 3-octene. Well, only double bonds here, single bonds here with 2 carbons. That's simply ethane. Here's a different one. We've got a hydroxyl group here. It's on the 2nd carbon. So this is 2. And 1, 2, 3, 4. That's butane, B-U-T-A-N. And remember that the OH tells me that it is going to end with OL because it is an alcohol. 2-butanol. And the last one here is, ooh, I've got a ketone here. I've got a ketone. So this is going to be my lower number. It's not 1, 2, 3, 4, 5. It's 1, 2, 3. So this is 3. And what's my long? 1, 2, 3, 4, 5, 6, 7. And that's heptane. And ketones have an ending of O-N-E. 3-heptanone. All right, so hopefully you got some more practice with those. Again, I want you to do the rest of these for homework through 14. And that's that, monkey cat. Okay? Have a good day.